This is a review of Unit 11 Study Guide, Inverse Variation. So you need to be able to determine if it's inverse variation from a table, a graph, and an equation. So if you are trying to decide if something is inverse variation from a table, you are going to make a third column. And that third column is going to be x times y. So if I go through here and I multiply x times y, I get 3 times 1, which is 3. Negative 9 times negative 3 is 27. And 0 times 0 is 0. What I'm looking for is for x times y to be all the same. So this first example, they are not all the same, so no, this one is not inverse variation. So let's try the second table. I've got x times y again for my third column. 1 times negative 8 is negative 8. Negative 2 times 4 is negative 8. But 0 times 0 is 0. So again, my answer is no, it's not inverse variation, and that's because x times y is not all the same. Our third table, we have x times y again. So 3 times 4 is 12. Negative 6 times negative 2 is 12. And 12 times 1 is 12. So yes, this third table is inverse variation, and that's because I multiplied x times y, and I got the same value for every single pair of points, every single set of points. All right, from a graph, you pretty much just need to know what it looks like. It looks like two curves in opposite quadrants. They're called hyperbolas, but it's two curves. And if you want to check on your calculator, remember that for inverse variation, the basic form is y equals k over x. So if you go to your calculator and you just enter in a number, say 5 divided by x, and hit graph, you can kind of see there and remind yourself what it looks like. It is two curves in opposite quadrants. So the first one is those two curves, so this one is a yes. This one is a line, so it's definitely a no. This one is a parabola, so it's not two curves in opposite quadrants, so this one is also a no. And then this one is my two curves in opposite quadrants, so this one is a yes. So again, on this one, you can always check in your calculator and just see what it looks like. But it should be two curves, opposite quadrants, two hyperbolas. All right, number 4, from an equation. Again, you need to remember this form, y equals k over x. So if you're trying to see if an equation is inverse variation, you need to see, is it in that form? So example 1, I can see, yes, I have y equals a number divided by x. So yes, that one is inverse variation. Second example is not solved for y yet. So if I was going to solve this one for y, I would divide by x, divide by x. That cancels out those, and I get y equals 10 over x. And again, this is in that form, y equals a number divided by x. So yes, my second example is also inverse variation. Third example is not. I don't have a number divided by x. And again, on these, I can always go back and check them on my calculator if I'm not quite sure. So if I wasn't sure if this one was, I could put it in 2x minus 4, hit graph, and I can see, no, this is a line, so it's not what it's supposed to look like. So my answer here is no. And then the same thing down here. I don't have a number divided by x. But if I wasn't sure, I could go put this in my calculator and say 3x squared plus 2x minus 10, hit graph, and I can see it's a parabola. It's not my two curves in opposite quadrants. So again, the answer to this one is no. Next part of inverse variation is writing an equation and then finding values of x or y. So again, everything with inverse variation is this, y equals k over x. So my first step for this problem, For the data in the table, tell whether y varies inversely with x. Okay, so if I want to tell if y varies inversely with x, I have a table, so I'm going to make a third column of x times y and multiply and see if they're all the same. So 3 times 2 is 6, 1 times 6 is 6, negative 2 times negative 3 is 6. So my answer is yes, it is inverse variation because all of my x times y's are the same. And that is actually my k value. X times y is my k, and k is all I need to write the equation. So once I've done that, if they're all the same, that's my k, and I can write my equation, y equals 6 divided by x. Another example, suppose y varies inversely with x. Write an inverse variation equation that relates x and y when x is 3 and y is 10. So the minute you read this part here, y varies inversely with x, you need to be thinking y you should be thinking y equals k divided by x. So now if I look, I have an x value of 3 and I have an x in my equation. And I have a y value of 10 and I have a y in my equation. So I'm going to substitute those numbers in. I'm going to substitute 10 for y, and then I am going to substitute 3 for x. Now to solve for k, I need to multiply both sides of the equation by 3. And I get k equals 3 times 10, or k equals 30. And again, the k value is all you need to write the equation. So once you have k, you can write your equation. My equation is y equals k, or 30, over x. That's the first part of the question. Second part of the question is, find the value of y when x equals 6. Okay, so again, I've got this equation, y equals 30 over x. And they're telling me that x is 6, and I have an x right here. So I am going to substitute that value in. Y equals 30 divided by 6. And now when I solve this, 30 divided by 6 is 5. So my answer is 5. Another way to do the second part of the problem is to put your equation in your calculator. So my equation is 30 divided by x, and go to your table. So second graph gives you table, and look for the value of x equals 6. So if I go down here, I can see when x is 6, y is 5. So that's the second way to solve this kind of problem. You either substitute or you look in your calculator. Okay, here's another one. Y varies inversely with x. So again, whenever you see that, you need to be writing y equals k divided by x. So now, just like the last problem, they're giving me an x value, and I have an x right here. And they're giving me a y value of 4, and I have a y right here. So I'm going to substitute. I'm putting in 4 for y, and then I have my k value still, and then I'm going to put in 9 for x. And to solve this equation, I multiply both sides by 9, and then I get k equals 9 times 4, or 36. So now I can write the equation. The question didn't actually ask me to write the equation, but I can't solve for anything until I have the equation. So I've got y equals 36 over x. That's my equation. So now I go back to my problem, and it says find x when y is 12. So I'm here, y is 12, and I have a y value here. So I'm going to substitute 12 equals 36 over x. So to solve this problem, the easiest way to solve it is to turn it into a proportion and then cross multiply. So when I turn this into a proportion, I have 12 times x, or 12x equals 36 times 1, or 36. Divide both sides by 12, and I get x equals 36 divided by 12, or 3. So my answer is 3. And again, the reason I turn this into proportion is I need to solve for x, and I can turn any number into a fraction by putting it over 1. So I have, instead of 12, I wrote it as 12 over 1 equals 36 over x, and then multiply 12 times x, and that equals 1 times 36. My other option here is to put it in my calculator, and I can say, okay, y equals 36 divided by x, go to my table, so second graph for table, and look for where y is 12. So I'm going to go down and try to see, oh, right here. Here's y is 12, and you can see when y is 12, x is 3. So that's another alternative. So quick review of direct variation, because you're going to be asked to tell whether something is inverse variation or direct variation. So we need to do a quick review of direct variation. Direct variation is a line, and it goes through 0, 0, and it never is horizontal, and it's never vertical. So if I'm trying to find if something is direct variation from a table, I'm going to make a third column, but my third column, instead of being y times x, is y divided by x. So here I have 1 divided by 3. I have negative 3 divided by negative 9, which if you reduce it turns into 1 over 3. And this here, I can't divide by 0, but unlike inverse variation, which never goes through 0, so if you see 0, 0 for inverse variation, it's definitely not inverse variation. Direct variation, by definition, has to go through the origin. So the fact that it goes through 0, 0 here means yes, it is direct variation. So you're not going to divide by 0, but you're going to look at this and you're going to know that it has to go through 0, 0. So yes, this is direct variation. You make a third column, it's y divided by x. From a graph, again, you just need to know it's a line that goes through 0, 0, and it can't be horizontal and it can't be vertical. So both of these are examples of direct variation. And lastly, from an equation, remember that it goes through 0, 0. So if I was thinking of y equals mx plus b, my m is my k, because my basic form here is y equals kx. So my m is my k, and my b is 0, because it always goes through 0. So really, when I'm writing this, what I had was y equals mx plus 0, and that's how we got y equals kx as my basic form. So I want to look at an equation and have nothing after x. And again, on these, you can always check them by putting them in your calculator. So I could put negative 1/2 x and hit graph and make sure that it's a line that goes through 0, 0. So as long as you've solved for y, you can check in your calculator. So the biggest difference between direct variation and inverse variation, direct variation, when my x increases, my y increases. So for example, if you work a job and you work more hours, you get more money. That is direct variation. Inverse variation means as one goes up, the other goes down. For example, if I am sharing a cake, if I share a cake among 10 people versus sharing a cake among 2 people, when I share the cake among 2 people, everyone gets half a cake. When I share a cake among 10 people, they get less cake. Everyone gets 1/10 of the cake. So think about direct variation as you're working a job, you work more hours, you get more money. Inverse variation, you're sharing a cake. The more people you have, the less cake you get.